In this video, we're going to focus on permutations and combinations. But what exactly is a permutation? And how is it different from a combination? A permutation is associated with arranging things in different order. Combinations, you're simply concerned about combining things. For a permutation, the order matters, but for a combination, the order does not matter. I guess the best way to explain this is with an example. Let's say if we have three letters, A, B, C. We could arrange them in this order, A, B, C, or we could say C, A, B. Now, even though we have the same three letters, the order is different. So these are two different permutations. The number of permutations is 2. However, the number of combinations is 1. These two are considered to be the same in terms of a combination, but in terms of a permutation, they're considered to be two separate things. So just make sure you understand that a permutation, the order matters, the way you arrange it matters, and for a combination, the order doesn't matter. You just want to combine things. So if you have ABC and CAB, you still have the same three letters combined in a group. So for a combination, they're the same. Let's use another example to illustrate this. Let's say if we have 4 letters, A, B, C, and D. And let's choose 2 of the 4 letters. In how many different ways can we arrange 2 of the 4 letters? And also, how many different ways can we combine 2 of the 4 letters? Make a list and use that to determine the number of permutations and combinations of choosing 2 out of the 4. And then we'll talk about how to use an equation to get that same answer. So we can choose AB, we can choose AC, or we could choose AD. We can choose BA, BC, BD. We're only using each letter once every time we select 2 out of the 4. We can also use CA, CB, and CD, and also DA, DB, DC. So notice that there's a total of 12 different ways we can arrange 2 out of the 4 letters. So the number of permutations in this example is equal to 12. Now what about the combinations? Now if you recall, for a combination the order doesn't matter. So take a look at AB and BA. In terms of permutations, these are counted as 2 separate things. But for a combination, you're combining the same letters. And since the order doesn't matter for a combination, they're counted once as a combination. So if we're going to count AB, we can't count BA. If we're going to count, let's say, AC, we can't take into account CA. If we're going to count AD, we have to eliminate DA. If we're going to use BC, we need to get rid of CB. If we're going to use BD, we can't use DB. And finally, if we're going to use CD, we got to get rid of DC. So notice that the number of combinations is equal to 6. 1, 2, 3, 4, 5, 6. So now you can clearly see the difference between a permutation and a combination. So just remember, a permutation, the order matters, and for combination, the order does not matter. Now, how can we calculate these answers? Is there an easier way in which we can find a value as opposed to making a list of all the different possibilities? The first equation you need to know is NPR. This helps you calculate the permutations. Now, there's 4 letters and we're choosing 2. So it's going to be 4P2. We're choosing 2 out of a group of 4. Now the equation NPR is equal to n factorial divided by n minus r factorial. In this case, we can see that n is 4 and r is 2. So n minus r, that's going to be 4 minus 2. Now 4 minus 2 is 2. So we have 4 factorial divided by 2 factorial. So what exactly is 4 factorial? 4 factorial is 4 times 3 times 2 times 1. You start with this number and you multiply 4 by every integer all the way to 1. 2 factorial is simply 2 times 1. So we can cancel 2 times 1. And we're left with 4 times 3, and we know that 4 times 3 is equal to 12, which is what we have here. Now, how can we calculate the combination? What is the formula that we can use? NCR is equal to n factorial divided by n minus r factorial divided by r factorial. So basically, in terms of a permutation, a combination is equal to NPR divided by r factorial. This portion right here is NPR, and then divided by r. So we have 4 C2 in this example. So n is 4 and r is 2. So this is equivalent to 4 factorial divided by 2 factorial times 2 factorial. And we know that 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And we have another 2 factorial. It turns out that 2 times 2 is 4. So we could cancel those 2's with the 4 on top. We could ignore 1 because 1 times anything won't change the value. So what we have left over is 3 times 2. 3 times 2 is equal to 6. And so now you understand how to use the equation, and also you understand how to make a list to determine the number of permutations and combinations. So now let's work on some example problems. In how many different ways can you arrange 3 books on a shelf from a group of 7? Now go ahead and try this problem. Pause the video, take a minute, and feel free to work on it, and then unpause it to see the solution. So is it a permutation or a combination? Does the order matter? Whenever you see the keyword arrange, typically it's a permutation. The order is important. So what we need to write is 7p3. We're choosing 3 books from a group or from a total of 7. So this is going to be 7 factorial divided by the difference between 7 and 3. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 minus 3 is 4, and 4 factorial is 4 times 3 times 2 times 1. So we can cancel these numbers, leaving behind 7 times 6 times 5. Now 6 times 5 is 30. And we know that 3 times 7 is 21. So 30 times 7 is 210. This is the answer. In how many different ways can we arrange 5 books on a shelf? How is this problem different from the last problem? And is it still a permutation? Well, we're still trying to arrange books, so the order matters. It's still a permutation. But you can use the fundamental counting principle to get the answer. So we want to arrange 5 books on the shelf, right? So there's 5 positions to place the 5 books. In the first position, we can choose any of those 5 books. So we have 5 options. Now, once we place the first book in the first position, there's 4 books left over to choose from. So we could put any of the 4 books in the second position. Now that we've placed 2 books, we have 3 left over. So we could put any of those 3 books in the third position. Now we have 2 books left over, so we could put any of those 2 in the second to last position. And in the last position, we can only put the last book there. So it's going to be 5 times 4 times 3 times 2 times 1. And that's another way in which you could solve these problems. 5 times 4 is 20. 3 times 2 is 6. If 2 times 6 is 12, 20 times 6 is 120. Now, in terms of a permutation, here's how you can calculate it. First, you need to find out what is the total number of books. In this problem, we only have one number. The total number of books is 5. And we're choosing all 5 books from a group of 5. So it's going to be 5p5. Using the formula NPR is equal to n factorial over n minus r factorial. N is 5, but r is 5 as well. So this is going to be 5 factorial over 0 factorial. Now this is not undefined. 0 factorial does not equal 0. 0 factorial equals 1. Make sure you know that. That's just something to know. If you're wondering why, that's just the way it is. I don't have an answer for you. So this is going to be 5 factorial over 1. And we know that 5 factorial is 5 times 4 times 3 times 2 times 1. And this is equal to 120. How many teams of 4 can be produced from a pool of 12 engineers? So is this a permutation or is it a combination? What do you think? Does the order matter? So let's say if I select 4 individuals, John, Sue, Sally, and Chris. Does it really matter if I select John, Chris, Sally, Sue? It's the same team of 4. So in this problem, the order doesn't matter. Therefore, it's a combination. So we're choosing 4 from a total of 12. So it's going to be 12 C4. And this is equal to n factorial, or 12 factorial, divided by n minus r factorial, that's 12 minus 4 factorial, times r factorial, or 4 factorial. So 12 minus 4 is equal to 8. Now, if you don't want to write 12 times 11 times 10 times 9 times 8 times 7 all the way to 1, here's what you can do. Notice that you have an 8 factorial on the bottom. So you want to write 12 just before you get to 8. So 12 factorial is 12 times 11 times 10 times 9 times 8 factorial. Because 8 factorial will go from 8 to 1, and you don't need to write all of it. Stop at 8 factorial because we can cancel it in the next step. Now 4 factorial, I'm going to write that out. That's 4 times 3 times 2 times 1. So let's cancel 8 factorial. That's going to save us some writing space. 4 times 3 is 12, so we can get rid of these two. And then 10 divided by 2 equates to 5. So what we now have is 11 times 5 times 9. 11 times 9 is 99. Now what is 99 times 5? Well, if you want to do that without your calculator, think of it this way. 99 is 100 minus 1. Let's distribute. 100 times 5 is 500. 5 times 1 is 5. 500 minus 5 is 495. And so we can choose 495 teams of 4 from a pool of 12 engineers. And so that's it for this video. Thanks for watching. If you want to find more videos that I've created in algebra, trig, pre-cal, calculus, chemistry, and physics, just visit my channel, and you can find my playlists on those topics. Well, I changed my mind. I just realized that there are some other problems that I need to go over that's related to this topic. How many different ways can you arrange the letters in the word Alabama? This is a very common question that you might see in this type of topic. And here's what you need to do. First, count the number of letters that are in the word Alabama. There's a total of 7 letters. So it's going to be 7 factorial on the top of the fraction. And on the bottom, divide by the letters that repeat. There's only one letter that repeats, and it's A. And A repeats 4 times. So we're going to divide it by 4 factorial. So therefore, this is going to be 7 times 6 times 5 times 4 factorial divided by 4 factorial. And so we could cancel these two, we know that 6 times 5 is 30, and 7 times 30 is 210. So that's how many different ways you can arrange the letters in the word Alabama. Let's try another example. What about the word Mississippi? In class, I've seen this a lot, so it's a very common example, so I'm going to use it. So first, let's count how many letters that we have. There's a total of 11 letters, so it's going to be 11 factorial on top, divided by, now let's find the letters that repeat. I repeats 4 times, so we're going to divide it by 4 factorial. S repeats 4 times, so another 4 factorial. And P repeats twice, so 2 factorial. So this is going to be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, divided by, I'm going to leave the first 4 factorial the same. I'm not going to change it. And the other 4, I'm going to write it as 4 times 3 times 2 times 1. And then 2 factorial, 2 times 1. So we can cancel 4 factorial. And let's see, what else can we cancel? Well, we know that 3 times 2 is equal to 6. So we could cancel those. And also, 4 times 2 is equal to 8. So we could cancel that as well. So what we have left over is 11 times 10 times 9 times 7 times 5. So 11 times 10 is 110, and 7 times 5 is 35. Now, 110 times 9, I believe that's 990. Now we need to multiply 990 by 35. And I'm going to use a calculator at this point. So this will give you 34,650. So that's the answer. And now that's it for this video. That's all I got, so thanks for watching and have a great day.